In section 12.2, number 25 is a suggested problem. What I'm going to do is a problem like that one. Find a unit vector that has the same direction as vector -4, 2, 4. So a little bit different notation than problem number 25, but we have our x, y, and z component in that order. So first of all, a unit vector is, there's a little formula associated with that. And so if we have a vector A, which we can write as bold-faced A, or an alternative notation is this A with a bar. So either is fine. Then a unit vector which is denoted as U, and is the vector itself, is 1 unit long, and it's in the same direction as a given vector A. And so the formula for that is just our vector, which we're denoting with A, over the magnitude of A. So that makes sense. Basically, we're just dividing by the magnitude so that we have that length scaled to 1. So the directions here could have just said find a unit vector for this particular vector. So don't be confused that it's kind of asking more than what is necessary here that has the same direction. A unit vector will have the same direction as your vector by definition. So let's go ahead and do this here. Notice the ingredients we have are our vector A, which in our problem is -4, 2, 4. And so that's, no problem whatsoever, it's just given. But the magnitude of A is something that we need to find. So before we get into that formula, let's just go ahead and find that. And I should be consistent here actually with my notation. If I'm going to use the bar for the vector, I should use it everywhere in that thing. And I use the bold-faced U here. Anyway, we'll leave that alone, I guess. Not be too picky. So anyway, moving forward here, let's go ahead and find that magnitude of our vector. So that little formula is the root of each component squared and added. So all we got here is -4 squared plus 2 squared plus 4 squared under that root. So taking each of those squares, oops, I guess I should show my work. It's going to be 16 4, 16, which is 36. And we got that nice perfect square again, same one as the previous problem, we get 6. All right, so that's not our answer. We're going back to the unit vector, which I guess I'll use this notation. And again, we got this crafty little formula for that. So our vector is -4, 2, 4. And our magnitude is simply 6. So division by a scalar, because the magnitude is a scalar, is the same as multiplication, and that you can think of just bringing that in to each of our spots up there. So it's the same as multiplying by 1, 6. And we'll have -4, 6, 2, 6, and 4, 6, which we can simplify that down to -2/3, 1/3, 2/3. So I'm just going to write this out, that our unit vector, again, is -2/3, 1/3, 2/3. And that's it.